Do you want to know what is reinforcement learning? Then this video is for you. In this video, we will discuss about what is reinforcement learning. Next, terms used in reinforcement learning. Next, we will discuss about key features of reinforcement learning. And next, what are the elements of reinforcement learning? And finally, we will wrap up with what are the three main approaches to implement reinforcement learning. Before going to these topics, if you are new here, this channel basically explains the concepts of AI, ML, DL and DS and motivates you to these fields. If you are interested, consider subscribing my channel. And if you don't know what is supervised and unsupervised learning, feel free to watch that video. Link is in the description. Now let's dive right into the topic. What is reinforcement learning? Reinforcement learning is a feedback-based machine learning technique in which an agent learns to behave in an environment by performing the actions and seeing the results of actions. For each good action, the agent gets positive feedback, and for each bad action, the agent gets negative feedback or penalty. In reinforcement learning, the agent learns automatically using feedbacks without any labeled data, unlike supervised learning. Since there is no labeled data, so that agent is bound to learn by its experience only. It solves a specific type of problem where decision making is sequential and the goal is long term, such as game playing, robotics, etc. The primary goal of an agent in reinforcement learning is to improve the performance by getting the maximum positive rewards. The agent learns with the process of hit and trial, and based on the experience, it learns to perform the task in a better way. Here we do not need to pre-program the agent as it learns from its own experience without any human intervention. In RL, the agent learns that what actions lead to positive feedback or rewards and what actions lead to negative feedback penalty. As a positive reward, the agent gets a positive point. As a penalty, it gets a negative point. Terms used in reinforcement learning. Agent, an entity that can perceive or explore the environment and act upon it. Environment, a situation in which an agent is present or surrounded by. In RL, we assume the stochastic environment, which means it is random in nature. Action, actions are the moves taken by an agent within the environment. State, state is a situation returned by the environment after each action taken by the agent. Reward, a feedback returned to the agent from the environment to evaluate the action of the agent. Policy, policy is a strategy applied by the agent for the next action based on the current state. Value, it is expected long-term return with the discount factor and opposite to the short-term reward. Q value, it is mostly similar to the value, but it takes one additional parameter as a current action. Key features of reinforcement learning. In RL, the agent is not instructed about the environment and what actions need to be taken. It is based on the hit and trial process. The agent takes the next action and changes states according to the feedback of the previous action. The agent may get a delayed reward. The environment is stochastic and the agent needs to explore it to get the maximum positive rewards. Elements of reinforcement learning. There are four main elements of reinforcement learning which are given below. Policy. A policy can be defined as a way how an agent behaves at a given time. It maps the perceived states of the environment to the actions taken on those states. A policy alone can define the behavior of the agent. In some cases, it may be a simple function or lookup table, whereas for other cases, it may involve general computation as a search process. It could be deterministic or a stochastic policy. Reward signal. The goal of reinforcement learning is defined by the reward signal. At each state, the environment sends an immediate signal to the learning agent, and this signal is known as reward signal. These rewards are given according to the good and bad actions taken by the agent. The agent's main objective is to maximize the total number of rewards for good actions. Value function. The value function gives information about how good the situation and action are and how much reward an agent can expect. A reward indicates the immediate signal for each good and bad action, whereas a value function specifies the good state and action for the future. The value function depends on the reward, as without reward, there could be no value. The goal of estimating values is to achieve more rewards. Model. The last element of reinforcement learning is the model, which mimics the behavior of the environment. With the help of the model, one can make inferences about how the environment will behave, such as if a state and an action are given, then a model can predict the next state and reward. The model is used for planning, which means it provides a way to take a course of action by considering all future situations before actually experiencing those situations. Approaches to implement reinforcement learning. There are mainly three ways to implement reinforcement learning in ML, which are value-based. The value-based approach is about to find the optimal value function, which is the maximum value at a state under any policy. Therefore, the agent expects the long-term return at any state under policy. Policy-based. Policy-based approach is to find the optimal policy for the maximum future rewards without using the value function. In this approach, the agent tries to apply such a policy that the action performed in each step helps to maximize the future reward. The policy-based approach has mainly two types of policy. Deterministic. The same action is produced by policy at any state. Stochastic. In this policy, probability determines the produced action. Model-based. In the model-based approach, a virtual model is created for the environment and the agent explores that environment to learn it. There is no particular solution or algorithm for this approach because the model representation is different for each environment. If you like this video, leave us a big thumbs up and subscribe to our channel for more updates like this.